Hey everyone, welcome back to your math class and to lesson number 24. Today we are going to be talking about quadrilaterals. So just before I get into the plan for today's lesson, I do want to apologize quickly for not being able to upload anything last week. It was a crazy week. I had to work 9 days in a row, and then I had some other stuff to do, and it almost became 11 days in a row. Um, so I just, with a lot of driving, a lot of moving around, a lot of work to do, I just didn't quite get the opportunity. I would have liked to prepare and record lessons for you guys in time for your classes. So I hope you enjoyed the videos that I had you watch uh, in place of my lessons last week. I heard that you did enjoy one of them. But today we're going to return to the unit that we were working on, which is geometry, and there was a little bit of geometry in the videos that I had sent your way for last week. But anyway, in the last lesson that I made for you guys, we talked about triangles and different ways to classify triangles, different ways that we can talk about triangles. And today we're going to sort of continue that discussion, but we're going to make it a little bit more advanced because we're going to be talking about quadrilaterals, which are four-sided shapes. So this is something I've mentioned before, that you've got quad meaning four and lateral meaning like side, so four-sided shapes. And that's what we're going to be talking about in today's video. So what we're going to start off with, because it's been a little while since my last upload, is we're going to do a brief review of the helpful markings that we use in our diagrams in geometry. So things like how we show that two lines are the same length as each other, or that two angles are the same size as one another. So we're going to talk about that first for a couple of minutes. Then we will get into a discussion of parallel and perpendicular lines. That's not going to be a very long discussion. It's just going to be a couple of minutes. I want to make sure everybody knows what those two words mean. And then after that, we will get into the different types of quadrilaterals, sort of the most common four-sided shapes that you're likely to encounter in the world, and some of their properties. And the idea of this video, along with the triangle video, but also, more so this video, is I want you to get used to using these like markings of, showing certain sizes and angles and things like that being the same as one another. The things that we talked about a little bit in our triangle video, we're going to use a lot more of that today, so that when we get into more advanced concepts, into more advanced discussions, where you've got more and more complicated diagrams going on in your problems, that I want to make sure you will understand these signs that you're going to see in this lesson when we get to the harder stuff. So that's sort of the focus of today, but we're going to also learn a few cool things about four-sided shapes in the process. So review, lines of equal length. So we talked about this before. We can show that two or more lines, so it doesn't have to be just two lines, but it has to be at least two lines, right? Are the same length as one another by putting the same number of tick marks through each line. So you can see that in this top side here of this rectangle and this bottom side here, we've got one tick mark going through the top and one tick mark going through the bottom. That's this tick right here and this tick right here. So because there's only one tick mark going through each of them, that's supposed to communicate to you that those two sides are the same length. Now, in the case of this rectangle, it might look pretty obvious, but if I were to hand draw a rectangle, that's where it becomes particularly useful, because if I were to say, pretend that this is a rectangle, if you were to actually measure out the lengths of these two sides with a ruler, you might find that it comes out to be a little bit different, might be off by a couple of millimeters or something, but I'm trying to tell you, relax, they're supposed to be the same size as one another. It's not supposed to be some weird shape you haven't seen before. So I put one tick mark through each of them to kind of communicate to you that they're supposed to be the same length. Now, similarly, the left-hand side of this rectangle and the right side are the same length as each other, but they're a different length from the top and the bottom. So to show that, there's two tick marks going through the left side, which I've marked in green, and we've got two tick marks going through the right side as well. which I've also marked in green. So marking the tick marks and having different numbers of tick marks, what that allows you to do is allows you to say that this side is the same length as this side because they've both got two tick marks going through them, but both of those sides are a different length from this guy down here and this guy up here because the number of tick marks is different. And so you could do, you could have some really weird like 10-sided, 15-sided shape, and you want to say that some of the sides are the same length as each other and some of the other sides are the same length as each other, then you can just use all these tick marks to kind of show that. And it makes work a lot simpler, both if you're talking about really complicated shapes, but also if you've got like a hand-drawn diagram and you want to communicate that. For instance, in this diagram, if I want to say that the left-hand side of this rectangle and the right-hand side of this are supposed to be the same length, even though if I were to put a ruler on my computer screen, they probably wouldn't be the same length, I can communicate that to you by putting 2 lines through this one and 2 lines through that one. And it doesn't have to be 1 line or 2 lines, like it doesn't have to be 1 line on the long sides or 1 line on the horizontal sides. It doesn't have to be anything like that. It just has to be the same number. So I could have done 3 here and here if I wanted to. I could have done 2 here and here if I wanted to. It just matters that it's the same, like for the top and the bottom, it just matters that they're the same as each other, but it doesn't matter that it's 2, 3, 1, 0, it doesn't matter. I mean, 0 might be a little bit weird because maybe you're not sure then if they are the same size. So at least 1 tick mark, going through the top and the bottom, but it could be 2, could be 3, could be 4, whatever works for you. I typically do just 1 and 2 instead of going to 3 if I don't have to, just to keep it easy. But anyway, that's about it for lines of equal length. So now we can talk about angles of equal size and right angles. So we can show that 2 or more angles are the same size as one another by putting the same number of arcs, these little like parts of a circle, like this thing, that's an arc, and this thing down here is an arc, and those guys up there, those are arcs, and those are arcs as well. So in this shape, what this is trying to tell you is that this angle down here, I'm just going to put a circle around it, so this angle here and this angle up here are the same size because they've both got 1 arc going through them, whereas this angle here and this angle here are the same as each other. So these 2 are the same as each other, but they're different from those 2 because there's 2 arcs in that and 2 arcs in that compared to 1 arc in the other 2 corners. So same kind of logic as the thing with the lines, except this time it's arcs with the angles. Now you will also find that, when we're dealing with, especially when we're dealing with triangles, that you'll just see arcs all over the place. Every time you're talking about an angle, you'll see an arc. So the angle thing we don't tend to use as much. But what I also want to draw to your attention is right angles. So remember that's 90-degree angles. Oh, that's no good. So something like this might be a 90-degree angle, but instead of putting an arc here and saying 90, what I do instead, what we in geometry do instead, is we put a little square here in the corner. So we make a little 90-degree angle of our own, we make a little square, and that's trying to tell you that this angle here is 90 degrees. So that's the idea of having that little square, and that's going to be important when we look at some of the quadrilaterals in this lesson, because squares and rectangles, they've got a lot of these angles, and it's important to be able to tell by looking at the diagram that, oh, that's supposed to be a right angle. So yeah, I just wanted to make sure that we're clear on that. Now we will move on to the new stuff. So now we're going to talk about parallel and perpendicular lines. So these are words that you might have heard before. Parallel lines are 2 lines that are pointing in exactly the same direction as each other. They will never get any closer to one another. They'll never get farther away from one another, and they'll never cross paths. So if you've got 2 parallel lines like this, they never get closer to each other. They never go farther away from each other. They never cross paths. They never, nothing. They're always exactly the same distance from each other. So for instance, something like this and Oh, well, those are getting a little bit closer to one another, but two lines that are pointing in exactly the same direction. Just, I'm doing my best, right, with my computer mouse. So that would be two parallel lines. That's two lines that are pointing in exactly the same direction. You can think of railroad tracks, right? The tracks that trains run on, those tracks are always pointing in, whoops, those tracks are always pointing in the same direction, right? You never see those tracks go like this, right, and have one cross the other. It's always, they're they're both equally far away from the other one at all times, right? Those tracks are two, they're parallel because they always have the same distance between them whenever you measure going all the way across. So railroad tracks are a really good way to think about parallel lines. And we can indicate that two lines are parallel by putting little arrows through them. So for instance, if I have two lines like that and I want to say, oh, these are parallel even if my drawing wasn't perfect, then I'll put a little arrow through this, and I'll put a little arrow through that. And that's supposed to say that those two lines are parallel to each other. So I could do the same thing with my guys up here in the corner. I could do an arrow there and an arrow there. Or same thing as with lines, is if I'm dealing with like different pairs of parallel lines, then I could put two arrows through this one, two arrows through this one to say that they're parallel to each other, but not to two other lines. So for instance, these two are parallel to each other, but they're not parallel to those two. So that's why we've got one arrow going through each of these and two arrows going through each of those, something like that. Perpendicular lines, on the other hand, are two lines that meet or that cross each other at a 90-degree angle. So that's the right angles that we talked about on the previous slide. So that's like, if you were to trace a line between where the wall meets the ceiling, like behind me, if you were to trace that all the way into the corner of the room, you'll get a right angle, right? You'll get a 90-degree angle when you see kind of how the wall meets the ceiling and then goes to the other wall. It's going to make a perfect 90-degree angle in the corner. So those are perpendicular lines. And then same thing if you were to, I'm not saying actually do this, but if you were to take a sheet of paper and you were to trace it out on the desk, you draw a line going, against the top side of your sheet of paper and then a line going down against the side of your sheet of paper. When you look at the desk that you just drew on, don't draw on the desk, when you look at the desk that you just drew on, you'll have two perpendicular lines because they'll be meeting each other at a 90-degree angle. So that's perpendicular lines, and they'll be easy to spot because we'll have that little box showing that it's a 90-degree angle whenever they show up. So with all of that said, we can now start diving into some different types of quadrilaterals. So we've got a few different ones on the screen. These are the ones that we're going to be looking at today. There are, other fancy, weird quadrilaterals that we could explore. I think we're going to leave it at this for today. But so these are the 6 main ones that we're going to look at. I'm going to show you kind of what sort of like tick boxes you need to check off in order for your quadrilateral to be one of these 6 things. And we're also going to practice drawing the diagrams to make sure that we understand how to use all these little markings. So let's start with the easiest of them all. We're going to start by talking about a square. So you're going to see the first bullet point is going to be the same on all of these slides. It's always going to say 4 sides because the first requirement for all of these quadrilaterals is that they are quadrilaterals, that they are 4-sided shapes. So it's going to be a 4-sided polygon. Maybe I should have said 4-sided polygon, but we're going to say a square has to have 4 sides, and all 4 sides have to be the same length as each other, and all the angles have to be 90-degree angles. So there's already a square diagram on the screen, but I'm going to draw another one beside it. So for instance, let's try not to do this with curved lines. So because I'm drawing with my computer mouse, it's not going to be perfect, but this is also illustrating the usefulness, the utility of these little markings. So the thing I've drawn on the screen is obviously not a perfect square by any means, but for, drawing with a computer mouse or something, or if you were to draw it on your test and it doesn't end up looking perfect, you could say, hey, relax, it's supposed to be a square, And here are the ways that you could indicate that. So first things first, you could say, well, for a square, all four sides got to be the same length. So I'm going to put the same number of tick marks through all four sides. I'm going to do just one tick mark through all four sides. You could do two tick marks through all of them, doesn't matter, as long as all four sides have the same number of tick marks, because that's what tells me, oh, okay, all four sides are the same length. Then you could say all four angles are 90-degree angles. So we can draw in those little boxes to show that the angles are supposed to be 90 degrees, even if they don't quite look like it. And then if we wanted to be a little extra, if we wanted to do a little bit more, we could say, well, the top side and the bottom side are supposed to be parallel to each other. So what I'm going to do is I'm going to put that little arrow through the top. I'm going to put a little arrow through the bottom to say that these are parallel to each other. And then I also want to say that the left side and the right side are parallel to each other, but they're not parallel to the top and the bottom, obviously. They're perpendicular. So for that, I can put a different number of arrows. So I'm going to put 2 arrows through the left side and 2 arrows through the right side. Oof, it's not a very good arrow, but that's the idea. So here is my diagram of a square, which just looking at the lines didn't really look like a square, but all of these extra markings are the geometry teacher, the geometry, the mathematician's way of telling you that all four sides are the same length as each other, all the angles are 90-degree angles, they're all right angles, the top and bottom sides are parallel to each other, the left and right sides are parallel to each other. So with all of these markings, you can look at this and go, oh, that's a square. Even if it didn't really look like one before, you can see, okay, all the angles are the same as each other and all the sides are equal length. That makes it a square. Pretty cool. So next one is a rectangle. So rectangles, very similar to squares, of course. So four-sided shapes, we know that. All angles have to be 90-degree angles, right angles, we know that. And opposite sides are the same length as each other. So again, just to practice, and I'm going to draw the rectangle on an angle this time, just to keep things interesting. So something like this will be my rectangle. Changed my color without meaning to there. Yeah, so what I want to do here with this rectangle is I want to show that this side up here and this side down here are the same length as each other. So to do that, I'm going to put a tick mark through here. I'm going to put a tick mark through there. That's saying that those two sides are supposed to be the same length. Next, I want to show that this side here and that side there are the same length as each other, but they're a different length from the top and the bottom. So to do that, I can put a different number of tick marks. So something like 2 tick marks, like this, like so. Then I want to show that all the angles are 90-degree angles. They're all right angles. So I'm going to put in that little square in each of the 4 corners. Forgive my mouse drawing, but something like that. And then I also want to say that this side up here and this side down here are parallel to one another. So I'm going to put one little arrow through there. I'm going to put one little arrow through there. And then I want to say that this side and this side are parallel to one another, but they're not parallel to the other 2 sides. So I'm going to put maybe 2 arrows through this and 2 arrows through that. Now, one thing that I sometimes like to do, and I haven't done it in this case, in the example of this rectangle, but I'm going to draw in a second one real quick. So if I had a really skinny rectangle, right? Don't worry that those aren't super straight lines. If I've got a really skinny rectangle and I want to say that, the left and right sides are equal to each other and the top and bottom sides are equal to each other, if I look at the left and right sides, they're really, really short, so I don't have a lot of room. So what I personally like to do most of the time, and I definitely did this more when I was younger, is I would make sure I put the fewest tick marks and the fewest arrows on the shortest sides. So that's not a rule, that's just something I personally like to do because, you know, sometimes you don't have a lot of space. So I would put just one tick mark here and one tick mark here, and then I would put just one arrow here and one arrow here, and then I would put the 2 tick marks on the bigger sides because I have more room to draw in these extra markings, right? So something like that, right? So you can do it however you like. You could do 2 tick marks on the long sides. You could do 2 tick marks on the short sides. You could do you could do like, for instance, I don't want to confuse you too much, but you could do something like 1 tick mark and 2 arrows on one of the sides, or one pair of the sides, right? So like on the red rectangle, I've done 1 tick mark here, 1 tick mark there, and 2 arrows, right? And then on the other 2 sides, I've done 2 tick marks and 1 arrow. So you can do it however you like. I personally would recommend, just from my own experience working with it, it's least confusing to me, and it might be least confusing to you, if you try and keep the number of tick marks and the number of arrows the same. I don't think that's actually a rule in geometry. I don't think you have to do it that way when you're making your diagrams. I just like to. I like to put the 1 tick mark with the 1 arrow. I like to put the 2 tick marks with the 2 arrows. And I like to put the fewest tick marks and arrows, the fewest markings on the shortest sides of my whatever shape I'm working with. So if I'm working with a rectangle, then on the short sides of the rectangle, I like to put just 1 tick mark and 1 arrow on each side. So hopefully that makes sense. Now the next shape we're going to look at is the rhombus. So the rhombus is a much less talked about shape. We see squares all the time, we see rectangles all the time. Rhombi, you could say rhombuses, but rhombi also show up enough in the world, but not nearly as much as squares and rectangles. So a rhombus is also a 4-sided shape, and all 4 sides of a rhombus are the same length as each other. So you can see that in the diagram at the bottom, that all 4 sides have just 1 tick mark through them. So that means that all 4 sides are the same length as each other. Now, opposite sides, so that means like the sides that aren't touching. So like the top and the bottom side, the left and the right side, you know, the sides that are farthest away from each other are parallel to one another. So if I were to draw out my own rhombus, something like that last one was no good, but the other 3 are looking all right. So something like that. There's my rhombus, right? So first things first, I want to say, okay, all 4 sides are the same length. So I'm going to put 1 tick mark through each side. Bam, there we go. All 4 sides are the same length. Then I want to say that opposite sides are parallel. So I want to say the top side and the bottom side are parallel to each other. So I'm going to put 1 tick mark through that and 1 tick mark through that. And then I want to say that the left side and the right side are parallel to each other, but not parallel to the top and the bottom. So I'll put 2 tick marks through this and 2 tick marks through the other side. Or not tick marks, 2 arrows through the left side, 2 arrows through the right side. So now we've said that all 4 sides are the same length, opposite sides are parallel to each other, and now we have to say that the opposite angles are equal to each other. So to do that, so again, opposite angles are going to be the angles that are farthest away from each other, the ones that if you were to stand on one side of the shape, this would be all the way across on the other side of the shape. So for the rhombus, the opposite angles, so like this one and that one over there are opposite angles. So those 2 have to be equal in size. So I'm going to put 1 arc here and 1 arc there. That's not a right angle, that's just an arc. I'm just making it a little bit thicker. And then the other 2 angles that are opposite to one another are this one down here and that one up there. Now, when you're doing a test and you're trying to show this with paper and pencil, you don't have to use different colors and stuff, but if you want to use different colors, you could totally do that too. So I'm going to put in 2 arcs. there, and there. And that's supposed to communicate that these two angles are the same size as each other, and those two angles are the same size as each other, but they're not the same as the other one, right? Like the blue ones aren't the same size as the red ones. Now, a minor aside here, if you will, like just a little not part of the lesson. Typically, and if any of you go on to, do like a math degree or a science degree in university, anything like that, when it comes time to make graphs, if you ever have to make graphs for any assignment and you make them on the computer or whatever, even if you're making graphs by hand, there's a good practice in math, which is to not rely on just color to tell things apart. So what do I mean by that? I mean that it's usually a good idea to have something besides color to say that these two things are not the same. So for instance, if I wanted to say, I've got like, if I'm making a little graph, a little fancy graph that you might see on the news or in a math textbook, and I want to talk about two different things and how they change over time, right? Like maybe this is the usage of the word yeet over time, and then, I don't know, this would be the usage of some other word over time, right? And then you can kind of look at how those two things have changed. Now on this graph, one of them is red and one of them is blue. And if you don't have any sort of color blindness, or you don't have super bad vision, then you can tell those apart no problem. But if I were to take this graph up here and I were to print it out on a sheet of paper and it came out in black and white, suddenly those two colors will look a lot closer. One of them might be a bit of a darker gray than the other, but they're going to be both gray lines, right? And what if I added another one? What if I added another color, something like that? The green and the red, if I were to print this out, are going to look really, really close to each other if I have to print them out in black and white, or if I have to look at them in a dark room or something. So something that's good practice in the case of graphs would be to use like dotted lines or something, that if I wanted to, instead of having like a red line, a green line, and a blue line, that I should have something like, one solid line and then one that's made up of a whole bunch of little dots, for instance, which obviously I'm not going to be able to draw that whole thing out. It's just going to waste our time. But you could have one line that's, a solid line, one that's made of dots, one that's made of dashes. And then it doesn't matter if you're looking at it without very much light, or if your vision isn't the best, or if you have sort of color blindness, or you're printing in black and white. It doesn't matter because you've got something besides color. You could use color. You could have the solid line be black. You could have the dashed line be red. You could have the dotted line be blue, whatever. But if you have this different style to them, that one of them's a solid line with no gaps, one of them's got dashes, one of them's got dots, one of them's got something else, then you've got something besides the color to tell them apart. So you could print it out in black and white or whatever. So same idea with the rhombus down here. Is I personally don't like it when you've got a diagram like, and you might see this if you go Googling like geometry diagrams of a rhombus on the internet, you might find something that looks like you've got your rhombus, and then they'll color this angle and this angle green, and then they'll color this angle and this angle yellow. And they'll only put one arc in each of them. But this makes it really challenging because now suppose I found that diagram and I wanted to print it out and give it to you guys in class. If it prints out in black and white, suddenly it looks like they're all the same. One of them might be a little, like the yellows might be a slightly lighter gray than the greens when I print it out in black and white, but they're going to be a lot closer in color. So a general rule of thumb is even on your, tests and quizzes, if you're writing it in just pencil, then you're going to have to do different numbers of arcs and stuff, right? You're going to have to do like one arc for the red ones and two arcs for the blue ones. But even if you have other pens or markers or crayons or color pencils, whatever you want to use for, to add a little bit of color, I would still recommend that you also do the two arc thing, just so that in case, somebody who's marking it, somebody who's looking at it later, either, is trying to do so in very poor light, or maybe they're colorblind and you don't know it. Like I'm not colorblind, but if I were and I didn't tell you that, then it might be hard for me to, mark a test that's got a whole bunch of things that I can only tell apart by yellow versus green. So it's just a good rule of thumb in math in general, but like you'll see it a lot. Any of you who might go on to do math and science in like a university degree, eventually you'll hear that when you're making your graphs, you can use these different textures and stuff to get around the problem of having too many things look the same and the only thing telling them apart being the color. That was a long, thing that wasn't really part of the lesson, but it is an important thing that I wanted to share, and this seemed like a good spot for it to kind of naturally come up. But anyway, that's it for the rhombus. Let's move on. So here we go. What makes a parallelogram a parallelogram? So a parallelogram is very similar to a rhombus, so it's a four-sided shape, and so it's similar to a rhombus in that the angles don't have to be 90 degrees. So I'm going to draw out my parallelogram here. Something like this. Right, so it's like a rhombus because the angles don't have to be 90 degrees. So I'm going to say, this angle and that angle are supposed to be the same as each other. I'm going to put two arcs there. And then I'm going to put one arc here and one arc here to say that those two angles are the same as each other, but they're different from the ones with two arcs. Right, so that's, I kind of jumped the gun, but that's this point down here. Opposite angles are equal, but don't have to be 90 degrees. So this bit was exactly true for the rhombus as well. The parallelogram is exactly like the rhombus, except you don't have to have all four sides be the same length. In terms of the side length, it's more like a rectangle, that the opposite sides have to be the same length, but they don't all have to be the same length as each other. So the rhombus is like the cousin of the square, and the parallelogram is like the cousin of the rectangle. So I'm going to say that the left side and the right side are supposed to be the same length, so that's one tick mark through each of them. The top side and the bottom side are supposed to be the same length as each other, but different from the left and right, so that's two tick marks. And then the left side and right side, you can see they're pointing in like, different directions because I've drawn it really badly, but I want to show that they're supposed to be parallel to each other. So I'm going to put one arrow through each of those. And then for the top and bottom, I'm going to put two arrows through that and two through that. And there we go. So we've got opposite sides are the same length, so the top and bottom are the same size as each other. The left and right are the same size as each other. Opposite sides are parallel, so the top and the bottom are parallel to each other. The left and the right are parallel to each other. And the opposite angles are equal. So it's like a rectangle that's a little bit slanted, just like the rhombus is a square that's a little bit slanted. All right, two more, and then we're done. What makes a trapezoid a trapezoid? So a trapezoid is a four-sided shape, a quadrilateral, that's got one pair of parallel, it says parallel lines, maybe this should say parallel sides. So if you look at the diagram down there, you'll see that the top side and the bottom side, they've got the little arrows through them. That's saying that those two are parallel. They don't have to be the same length, and the other two sides don't have to be parallel to each other. So I could have two lines like this, and then one like that, and one like that. And I'm saying if the top side and the bottom side are parallel to each other, and that's it. They don't have to be the same length. The other two sides don't have to be anything. There doesn't have to be any 90-degree angles or anything. This is a trapezoid. And that's all there is to it. The markings are a lot easier on this one because we don't have to mark a whole bunch of other stuff. And the last one that we're going to look at is a kite. So a kite is a four-sided shape that's got two pairs of sides that are the same length as each other, but instead of it being the opposite sides, it's going to be two sides that are touching each other. So these two sides will be the same length, and these two sides will be the same length. So you can see that in the diagram, but I'm going to draw that a little bit bigger. So a kite is one where you've got four sides like this. Sorry about that mess at the bottom there, but basically for a kite, this side and this side will be the same length. This side and this side will be the same length. There's no rules about anything having to be parallel to each other, but you will find that this angle and this angle are the same as each other. So that's that last point up here, one pair of equal angles. That's these ones here. So where you've got two equal sides up here, two equal sides down here, and where they meet, you'll have equal angles. So that's it. That's all there is to a kite. Now, you'll find that some quadrilaterals fit multiple different categories. So for instance, squares are like the ultimate quadrilateral because they fit the bill of everything that you need in order to be a rectangle, everything you need in order to be a rhombus, everything you need in order to be a parallelogram, a kite, whatever, right? Pretty much all of these regular quadrilaterals, a square fits the bill for all of them because think about it, for a rectangle, you need to have 4 right angles, squares got them. The opposite sides are equal length. Squares got that. Top and bottom are the same. Left and right are the same. Top and bottom sides are parallel. Got it. Left and right sides are parallel. Got it. For the rectangle, it's basically saying for a rectangle, you take a square and then it doesn't matter if all 4 sides are the same length. You can kind of stretch it out. The square is just saying, okay, what if I don't stretch it out? It's still a rectangle. You don't have to be, different. You don't have to have different lengths of the sides in a rectangle. For a rectangle, you can have different lengths for these sides versus those sides, but you don't have to. So a square is a special kind of rectangle. Same thing with the rhombus, right? A rhombus is a shape that's got all 4 sides are the same length, but the angles don't have to be 90 degrees. But if they are 90 degrees, that's a square. 4 sides that are the same length, 4 angles that are 90 degrees, that's a square. It's also a rhombus, but it's a square. So some shapes you'll see fit different types of categories. Just how, like I said, that the rhombus and the square are cousins, it's really that the square is a special kind of rhombus, the rectangle is a special kind of parallelogram, the square is even a special kind of parallelogram. So that's something that you guys can think about to kind of break your brains if you hadn't thought of that before. And the last thing I want to say for today is that you'll also find that there are some quadrilaterals that don't fit any of those categories that we've talked about. So these are irregular quadrilaterals. So these are ones that they don't fit the categories that we talked about. So they, maybe none of the sides are parallel to each other, or maybe they're all four sides are different lengths and all 4 angles are different. And you can see in this diagram that they've done a really good job of marking that. So we've got 1 tick mark up here, 2 tick marks here, 3 down here, and 4 over there. So that's saying that's 4 sides of completely different lengths, even if they don't look like it. And then we've got for the angles, we've got 1 arc here, 2 arcs here, 3 arcs here, and 4 arcs there. So that's saying that all 4 angles are different as well. And that's saying that this is an irregular quadrilateral. So that is all for today. I hope that all made sense. And as always, if you have any questions, please do not hesitate to reach out in a YouTube comment, in a WhatsApp message, in an Instagram message, whatever works for you. I will do my best to check things regularly. I know it's been crazy for the last little bit, so if any of you have left comments in the past week, I do apologize for not getting to them sooner, but I'm going to check those right when I go to upload this video. So yeah, I hope everything in this lesson made sense. Thank you for your time and attention, and I will see you all in the next video. Have a good one.